Zinc is added to solution of magnesium sulfate. Will zinc displace the magnesium from the solution? So we're starting with zinc. Okay, so let's go find ourselves some zinc. There's some zinc over there. Oopsie, there's some zinc. And we're going to solution of magnesium sulfate. So it's going to be Mg2 plus. So there's the magnesium 2 plus. So if you think about it again, what are we getting? Sorry, let's go into pen. We need to start at the zinc. Okay, this is where we're starting, is the zinc. Is added to a solution of magnesium 2 plus. Okay, will the zinc make us get magnesium? So how would this work? This would go from here to here, then we'd have to go up, and then we'd have to go across. Does that work? No, it doesn't, because we said our shape had to be a C. So therefore we can say immediately that that does not work for us, and therefore this is not right. Okay, another way to think of it this way is that, do you agree that on the redox table, as you go down, this is the increasing oxidizing ability. Okay, and as you go up the table, it's an increasing reducing ability. So what does that mean? If it's an increasing oxidizing ability, it's being reduced. So therefore we're saying that zinc has got to go to zinc 2 plus, sorry, reduced. Okay, if it's reduced, it's got to lose electrons. Okay, so the point is that if we had, this is increasing oxidizing ability. So if it's an increasing oxidizing ability, then do you agree that you're going to end up with this being the reducing aid being reduced and this being oxidized? For magnesium to be oxidized, it's magnesium sulfate to be oxidized, it has to lose electrons. Okay, that's what we're saying. In other words, in order for this to work, okay, this bit here at the top is supposed to be oxidized. Okay, so in other words, it's supposed to be losing electrons, not gaining them. Yeah, magnesium 2 plus is gaining 2 electrons to form magnesium. So the only way this reaction works is if it was going from magnesium to magnesium 2 plus and from zinc 2 plus to zinc, not the other way around. Okay, now it says if aluminium is added to solution of cobalt sulfate, will the aluminium displace the cobalt? Okay, so let's try this one. Let's go. So we want aluminium. So we need aluminium, and the letters for aluminium are Al. So let's go find some Al for us. So let's go look. Barium, calcium, sodium, aluminium. There we go. So there's our aluminium. It's added to a solution of cobalt sulfate. So it's going to be cobalt is CO and it's CO2. So now we need to find some cobalt. There is some cobalt now entirely. Okay. Do you see what's wrong with this one? This one is CO3 plus an electron gives you CO2, and they've asked us to form cobalt. So we can't be going around forming cobalt ions. We want pure cobalt. Okay, so if that's the case, if we look at this, we've been given aluminium, okay, and we are going from cobalt ions to cobalt. So we're going from given aluminium, going from cobalt ions to cobalt. Yes, it works, it forms a beautiful C. Except grade 12, you can't say it forms a beautiful C in the exams. You need to explain. So what you need to say is that the aluminium ion, okay, the half reaction for the aluminium, what is it, 3 plus, yeah, plus 3 electrons goes to aluminium, has an EMF of negative 1,66, and the CO2 plus 2 electrons goes to CO, has an E theta of minus 0,28. Therefore, we could say that therefore this is slightly more positive, so it's more likely to be reduced. Oxidation reduction, yeah. Because if it's more positive, it's going to gain the electrons, okay? So if it's reduced, then it's gaining electrons. So that works, which means this is more likely to lose electrons. The reaction is going to be aluminium goes to aluminium 3 plus 3 electrons. And similarly, cobalt 2 plus 2 electrons goes to cobalt. And then, yeah, okay, and then you can balance it, etc. But they haven't asked us to do that. Okay, so do you understand how this works? In fact, let's just show you how this would work, because I think it's important that you be able to do the half reactions. So the next step that we would do is that we'd have to balance the number of electrons. So in order to do that, just like with maths, you times the top by 2 and the bottom by 3, because what are we doing? We're balancing the electrons. So this becomes 2, 2, and 6, and this becomes 3, 6, and 3. So it becomes 2 aluminium plus 3 CO2 plus goes to 2 aluminium 3 plus 3 CO. There you go. So there you go, CO. And that's a little O. Just a second. Let me just fix some, because at the moment that says carbon monoxide, CO and CO. There you go. So that's your balanced half reaction. Balanced overall net reaction.